All right, we're on Geometry 9.02 notes today, which are on similar triangle proofs. I know your favorite thing. So, with similar triangle proofs, you're going to be looking for a couple different things in your proof statement. So, something like this, where you have a proportion, is one thing. So, we know that when we have similar triangles, our sides are in proportion. So, let's go ahead and look at our givens. We've got AE and DB. It's just saying those are straight lines, so not a whole lot that they're giving us. And then we also know that AB is parallel to segment DE. So we know that's true, so we can conclude that if two lines are parallel, then you can find those Z's in there, and we can get some congruent angles. Also, going the other direction, we'd have angle D congruent to angle B. Now, that is actually enough information to get those two triangles similar. So our goal here is to get triangle DCE to be similar to, and I want to match these up correctly, so D goes with B because those have two marks. C would be those vertical angles, so you could also get those congruent, BCA. So if I can get these two triangles to be similar, then I know that their sides will be in proportion. So DC over BC equals DE over BA. All right, so first we'll start with our givens. So we've got segment AB parallel to segment DE. So from there, we can now conclude that angle D is congruent to angle B. So I am allowed to use one letter on these. If you wanted to put a number in each of them, that's fine too. Or you can name them with three letters. But because they're the only angle at that letter, you can use just one. And I know angle E is congruent to angle A. And the reason those will be congruent is if two lines are parallel, then alt interior angles are congruent. So you're welcome to say here that angle DCE and angle ACB are congruent because vertical angles are congruent, but we really don't need that because here we have those two angles. And we know the actual most common way to get two triangles similar to each other is angle-angle similarity. So now I can say that triangle DCE is similar to triangle BCA by angle-angle similarity. And we had both of those angles right here. All right, so now I can say that side DC over side BC, so those are corresponding sides, the first two letters in each, is equal to segment DE, which is this side, over segment AB or BA. And the reason we know that is that once these triangles are similar, we know that corresponding sides of similar triangles are proportional or are in proportion. We don't have a special saying there. There's no CPCTC, nothing like that. We just actually write it out as corresponding sides of similar triangles are proportional. So the other thing you might see that we'll talk about in a minute is you could cross multiply those, which would bring us one step further there. But here we're just getting, as soon as you see a proportion that you're trying to prove, you should be thinking similar triangles. How can you get those triangles similar? Quick refresher here, to get triangles similar, we have three different ways. One of them is angle-angle. The other is side-angle-side, which means two pairs of the sides are proportional and an included angle is congruent. And then the last way is side-side-side similarity, which is when you get all three pairs of sides proportional to each other. All right, next up, given parallelogram ABCD. So here's where you see something like this. Typically you see it with the dots instead of the X's there. But we're looking at, and sometimes it helps to color code it here. So KM and LB. So those do not look like they're part of the same triangle. So I'm going to do them in different colors. And then we have LM. So that looks like it's part of the pink triangle. And KD looks like it is part of the purple triangle. So now if I connect those to make triangles, I've found all these parts. So now that helps me to figure out which triangles I want to get similar to each other. So now my goal is to get triangle BLM similar to triangle. And here's where we're going to kind of guess right now. So we could always change this in our proof, but maybe DKM. So our goal is to get these two triangles to be similar to each other. We are given that we have parallelogram A, B, C, D. So we know we have 5 different conclusions from a parallelogram. Remember, we can say opposite sides are congruent, opposite sides are parallel, opposite angles are congruent, consecutive angles are supplementary, and the diagonals bisect each other. Probably not going to say anything about our diagonals here because we don't have the other one drawn in. But you could look for congruent sides. We also typically, with similar triangle proofs, want to be looking for angles and seeing if we can get angle-angle similarity or that angle in there. I do look at these triangles and I see I've got a pair of vertical angles that I can get congruent. And now I also know that the opposite sides are parallel to each other in a parallelogram. And then try to see if you can find a Z here. So pause the video and see where you can go from here. All right, so hopefully you notice this Z right here. And that Z means that we've got alternate interior angles congruent. And with that, you also actually could have done this Z as well. If you want to save a step, instead of doing the vertical angles, there we have our another Z. So those are also parallel lines cut by a transversal. So now we can get these two triangles to be similar by angle-angle similarity. Also, I'm going to double check while I'm thinking about it, double check my statement here. So B should match up with D, L with K, and M with M. So it looks like we guessed correctly, but just want to double check that, of course. All right, so now let's talk about how we possibly are going to get to this. So first of all, we found similar triangles. Once we have similar triangles, we want to know that our corresponding sides are in proportion. Another way of thinking about it is by working backwards from this. So we know we have KM. So if I put KM here, if I want to cross multiply to get this, LB needs to be multiplied by KM. So that needs to be along the other the diagonal right here. Because I'm going to, by cross multiply, multiply along here. And then LB is in the bottom. So I want to compare KM right here to which side. So there's a couple ways you can think about it. You can either make the first fraction all of one triangle and the second fraction all the other, or you can compare sides and keep the one triangle on the bottom and the other triangle on the top. So if I have KM over here, then the other segment in that triangle would be KD. So KD, you'll see, is across from LB. And then you could put our LM up here, or you could write it as KM over, so KM will correspond to, so that's between the 3 marks and the 1 mark, so that would correspond to LM. And then KD, which is over here, which is between the 2 and the 3, would correspond to LB between the 2 and the 3. So either one of those would work, and meaning if I cross multiply these, they would give me this this product right here, this equation. All right, so let's go ahead and write this out. So we've got our given. We're given parallelogram A, B, C, D. And now I need to get the triangles to be similar to each other. So again, we can use vertical angles, or we can just use our alt interior angles. But in order to get those alt interior angles, I need to state that my segments are parallel to each other. So segment BC is parallel to segment AD, because in a parallelogram, opposite sides are parallel. Now I can state, and here you might want to include numbers in your angles to make it a little easier, or you can list them with 3 letters, but none of these angles can be listed with a single letter. They all have more than one angle at them. So I could say angle LBM is congruent to angle MDK, and angle BLM is congruent to angle DKM. And that's because if 2 lines are parallel, alt interior angles are congruent. So that gives me my 2 angles. So now I can say that triangle BLM is similar to triangle DKM by angle-angle similarity. And now I can work one of these, and I can choose whichever one I want. I'm going to do KM over LM equals KD over LB. And again, same reason as before, corresponding sides of similar triangles are in proportion, or are proportional. But that's not what we're trying to prove. We're trying to prove this statement here, this equation. So now I can cross multiply to get Km times Lb equals Lm times Kd. And we usually say for that the product of the means equals the product of the extremes. What does that mean? That just means cross multiplication. And saying that in that way is just saying that the means are this along this diagonal right here, and the extremes are along this diagonal. Think about it as if you were reading in columns, the first one you would read is Km, then Lm, then Kd, then Lb. So your extremes are your first and your last numbers here, or in this case, letters, and the means are the middle ones that you'd have here. So again, you guys want to recognize that whenever you have a product like this equation right here, or if you're asked to prove 2 triangles similar, or like in number 1 where you have a proportion, those are all hints to you that you have a similar triangle proof. All right, let's try number 3. So number 3 is given triangle ABC is isosceles with base segment AC, and angle 1 and angle 2 are right angles. So I'm going to mark my picture, write out my givens. Isosceles with base AC, and angle 1 and angle 2 are right angles. So knowing this is an isosceles triangle, I know that I'm going to have congruent sides as well, and congruent base angles too. So those are just some things I want to mark before I start making my plan here. So I want to prove that AE, and here's where I'm going to use my colors. So AE, I'm going to make purple. BD is not part of that same triangle, so I'm going to make that pink. Equals CE. So CE looks like it was going to be part of the purple triangle because it cuts through the pink. and DC. That's going to be your pink. So now I can figure out what two triangles I'm actually talking about here. And since I see this is this product equals another product, I'm thinking similar triangles. So I want to get the pink triangle similar to the purple triangle. So I want to get triangle AEC similar to triangle. I'm going to try and match this up here. So A has this congruent angle at it, so that looks like it's going to match up with C. And then E is the right angle, so then it's going to go to D, the right angle, and then B. So it looks like I actually already have some enough markings here to get those two triangles congruent by angle similarity. All right, so I would like you guys to pause your video and try to complete this proof on your own. All right, so first of all, I've got two right angles. I need to get those congruent. So angle 1 is congruent to angle 2 because all right angles are congruent to each other. So that gives me an angle there. Now I also know that angle A, and I can't call this one angle C because there's more than one angle at it. So angle A and is congruent to angle BCA because in an isosceles triangle, base angles are congruent. And that gives me another angle. Now, if this is hard for you to see, feel free to draw it outside of the picture too. So this is CDB. I know that angle 2 is a right angle, and then this angle here is congruent. And then here's angle 1, we know is a right angle, angle A. So here you can see that we have two congruent angles. If that helps you, anytime you have overlapping triangles, just redraw them. You could even color code them if you want, keeping this one purple and this one pink, if that helps. All right, so now we have enough to say that triangle AEC is similar to triangle CDB, and we know that is by angle similarity. So we want to get this product equal to the other product. But before we can do that, we need to set up our proportion so that we can cross multiply to get that. So to set up our proportion, I know that I have AE, and that's going to have to multiply by BD. So those have to be along my diagonals. So now I can either do AE over CE or AE over DC. So AE looks like it's going to correspond to DC, so I'm going to put that over DC. And BD corresponds to EC or CE, so I'm going to put that over here. And the reason you should have there is corresponding sides of similar triangles are proportional. And then your last step here is to cross multiply. So AE times BD equals CE times DC. And we like to say our official reason here is the product of the means equals the product of the extremes, which really just means to cross multiply. All right, and our last one for today is proving a theorem. So prove the theorem that two isosceles triangles are similar if the vertex angle of one triangle is congruent to the vertex angle of the other. All right, so let's talk about our given. So first of all, we know that the two isosceles triangles are similar if the vertex angle of one triangle is congruent to the vertex angle of the other. So remember, your given is always your if, the prove is your then. So my given would be if the vertex angle of one triangle is congruent to the vertex angle of the other. So let's call angle A and angle D our vertex angles. So we know that angle A is congruent to angle D. We also know that both of these triangles then are isosceles. So triangle ABC and triangle DEF are isosceles triangles. And are then, so just kind of switched here, the order. We want to prove that triangle ABC would be similar to triangle DEF. All right, so first let me write out my givens. Angle A is congruent to angle D, triangle ABC, and triangle DEF are isosceles. So remember, we're proving a theorem here, so we just can't use that theorem. Pause the video and see if you can come up with a plan as to how you're going to prove this. And if you're ready, you can even go ahead and give it a try. Okay, so because we know these are isosceles triangles from our given, we also know that these two sides are congruent and these two sides are congruent. We don't know that they're all congruent to each other. These could be two different sizes. They could be the same size. We just don't know. We don't have enough information. So I know that segment AB is congruent to segment AC, and I know that segment DE is congruent to segment DF. And the reason there is an isosceles triangle has two congruent sides. All right, so how are we going to get these to be similar? Well, we know we already have an angle in each. So now if we know that these two sides are congruent, and we know these two sides are congruent, let's say this was 3, and this was 6. So this must also be 3, and then this must also be 6. 3 over 6, is that equal to 3 over 6? Yes. If this was 2 and these were 5, is 2 over 5 equal to 2 over 5? Yeah, so are the sides in proportion to each other? Are two pairs of sides in proportion? Yes, so how do we write that? Because if we know they're proportional, these two with these two, and we have the included angle congruent, we can get those triangles similar by side angle side similarity. But to do that, we need to have, so we already have an angle. We need to get the two pairs of sides to be proportional. Well, I know right here that they're congruent. And if you go back, way back to our boxes, we know that if you have two sets of equals, we could do AB plus DE equals AC plus DF. We could do AB minus DE would equal AC minus DF. We could do AB times DE equals AC times DF. And we can do AB divided by DE equals AC divided by DF, which would give us our proportion. But before we can do any operations, you have to have them in equality. So AB equals AC, DE equals DF by def of congruency. And then we can say that we've got, let's do our division. So I can now take AB over DE is equal to AC over DF. And the reason for that is just your division property of equality. So not one we've really used too much in the past. All right, so that gives me my two pairs of sides proportional to each other. So now I can say that triangle ABC is similar to triangle DEF by side angle side similarity. So that one doesn't come up as much as our angle angle similarity, but that's exactly how you would do it when it does. All right, and that is our last proof for today. If you have any questions, again, be sure to let me know. And I would be happy to go over any of these again if you would like. All right, I hope you have a great day. I hope to see you soon, and pie out. I don't know, this new computer, I think it paused it too early. I wanted to make sure you guys heard my pie out. All right, pie out.